Okay, let's work through some of these unit conversions together. The first question we have here is, if the price of gas is $1.10 per liter, how much will it cost to fill a 40-liter tank? So let's start with this process of unit analysis. What I want equals what I have times what I know. And I'm going to write what I know in red just to keep it separate in our minds, because this is the conversion factors that we're going to use to convert from one unit to another in our calculation. So the first step is identifying what do I want and what do I have, and then finally what do I know? What conversion factor am I going to use? What you want is what's being asked of you in the question. So here, if the price of gas is $1.10 per liter, how much will it cost? There is what we want right there. How much will it cost? And we'll assume that that's in dollars because we're talking about money. And what do I have? There's two pieces of information here. There's a 40-liter tank that we're filling. So there's one piece of information. And the other piece of information is that the price of gas is $1.10 per liter. Sometimes in chemistry, it can be a little bit confusing to determine which piece of information will be your conversion factor and which will be your starting point for your calculation. A tip is, when you're looking at the question, if you see a statement that relates two different units, such as the price of gas is $1.10 per liter, notice that this relates liters of gas with dollars. Okay, that will be an obvious conversion factor. This is a rate or just a statement that relates to units. So that's actually going to be our conversion factor. That's what we know, which means that the 40-liter tank is what we have. So our 40-liter tank is our starting point. So let's put that into our calculation. 40 liters times what we know. And I'm going to, over to the side here, underneath my conversion factor, I'm going to write $1.10 per liter in a little different way. And I'm going to write it like this. $1.10 is equal to 1 liter. So I've written it like that as an equation, as a statement, because when I go to put it into my calculation, which is what I'm about to do next, it allows me to just think about where I want to put the different units in the numerator and the denominator so that I correctly convert out of liters and into dollars. Okay, let's go ahead and do that now. So I'm going to put in my conversion factor, and it's important that I put the 1 liter on the bottom in the denominator of this conversion factor, like so, because I'm trying to cancel out of liters. So if I have 40 liters in my calculation, that's what I have. I need to ensure that when I put in my conversion factor, liters is directly across from that so that it cancels. In other words, liters divided by liters is 1, okay? And those units will cancel. So that helps me identify which way do I want to put that conversion factor in. I always want to put it across from the units that I'm trying to cancel. I'm going to put the other half of the conversion factor, $1.10, up on the top in the numerator. And right away, cancel out those units. Get rid of liters, and now I can see that the only unit I haven't canceled is dollars. And so I'm ready to calculate this answer out, okay, because what I want in dollars is the only unit that I have left now in my calculation. So I'm ready to do it. It's 40 times 1.10 divided by 1. I really don't need to divide by 1 in my calculator or multiply by 1 if you see that in a calculation, because it's going to give you the same answer. So it's 40 times 1.10, and my answer is going to come out to be dollar signs, $44. And I'll put 2 decimal places here because we're talking about money. A little later in this course, we're going to talk about significant figures, but we're not dealing with those yet. So $44 is our correct answer. And it's really important here that we include our units. Okay, always in chemistry and in science and math, always, include units in your answer. If you don't include units in your answer, not only will you lose some marks, but more importantly, it leaves it open to interpretation. And a person looking at your answer is not sure whether that's dollars or cents or thousands of dollars. So it's important that you always include your units so that you're being specific about what you've calculated. Let's do another example together. Here I've got, if 0.200 milliliters of gold has a mass of 3.86 grams, what is the volume occupied by 100 grams of gold? Okay, let's again start our calculation off as we always do. What I want is equal to what I have times what I know. All right, and just to be consistent here, let me write what I know in red, just to identify what those conversion factors are. So remember that what you know is your conversion factors. And sometimes you have more than one. Okay, and let's go ahead and start by figuring out what is it that I want. So if I read this question again, it says, what is the volume? So there's what I want right there. Volume is what I want. So I'll write that into my calculation. What units am I looking for? This question actually doesn't specify any units, so you would be fine if you wrote any units of volume here, okay? But again, we want to make it easy on ourselves. If we get to choose what units we're going to report our answer in, it makes sense to look at the information in the question and take the easiest route. So here I can see that I have this statement, 0.2 mils of gold has a mass of 3.86 grams. I know I'm going to be using this statement somewhere, and I see that it uses a volume, units of volume of milliliters, so it just makes good sense for me to assume that my answer here is also going to be in milliliters. Okay, but if you chose liters, that wouldn't be incorrect. Okay, what do I have? What am I starting with? Again, I've got two pieces of information. One is that I've got 100 grams of gold. The other piece of information I have is that 0.2 mils of gold has a mass of 3.86 grams. Remember, just like in the last question, if you have a statement that connects two different units, there is your conversion factor. So here, I'm going to write that out over here to the side. I'm going to write it out as again as a statement, an equation. So 0.2 mils, okay, is equal to 3.86 grams. Okay, and I've written it out like that so it's easy to plug into my conversion factor. That means that what I have, my starting point, is this 100 grams of gold. So let's put that in there. 100, keep all of the digits that you see. Okay, don't round it up to 100. 100.0 grams, keep your units in your calculation. Times what I know, this is going to be written in like a fraction. And again, think about what are we trying to cancel? We're trying to get out of grams. So I need to take my conversion factor right here. Oops, sorry. This conversion factor is going to go into my calculation, and I want to have that 3.86 grams on the bottom because I want to cancel out of grams. The other half of it, 0.200 milliliters, is going to go on the top. And right away, I cancel out my units of grams, and I'm only left with milliliters. That's what I want. I'm ready to calculate this out. So my volume is equal to 100 times 0.2 divided by 3.86, and my answer comes out to 5.18. Am I done? No, I'm not. I must put my units in my answer. There they are, milliliters, and there's my final answer. As we get into some more complicated calculations in this unit and in later units as well, this process, what I want equals what I have times what I know, is one that we encourage you to use. It helps you set your calculations up in a way that is good practice, but also it allows you to keep track of your units as you're doing your calculation, and it guides you because the way you put your conversion factor in allows you to look and see which units you're canceling. So in other words, it's very unlikely that you're going to use your conversion factor incorrectly if you're using this process, because you're allowing your units to guide you. You're always thinking about, how do I put that conversion factor in? In other words, will I be multiplying or dividing? Very often when students do these calculations in their head, or they do them in little separate calculations down the page, it's easy to make a mistake, and all you need to do is make one error and you have the wrong answer. So this process is a really, really useful one for you to just get in the habit of it. I know at first it's a little bit frustrating, but once you've got it, not only does it apply in chemistry, but in physics or math, and really any science course that you do. So let's go ahead and carry on with our lesson, and you can try some of these on your own.